Just want to take a quick walkthrough of the Self-Winding Clock Company catalog. This was printed in 1908-ish or thereabouts. And let's see if I can get less glare. I don't have a tripod or anything, so it talks about the clock types, the movements, type A, type E, and of course the type F, which is the one that I've got. And here's a description of how it works. Every hour it winds, and every hour it synchronizes. And there's some other, there's a type F without a synchronization solenoid. And it gets into, you know, the clock styles and all kinds of cool stuff. Probably the most interesting part is how you buy the time service itself. So it was provided via Western Union, and so what you would do is you'd pay a certain amount per quarter to have your clock synchronized if it was a type F movement. And you can see how the network was set up. Everything was synchronized to the U.S. Naval Observatory in Washington, D.C. And here are the pulse sequences transmitted via the telegraph line. And these are some images of the regulator clocks that you might have. This is kind of like the one I've got, except I don't have the decorative carvings, and my dial is a black and white. And then here's the costs per year. I expect payment in advance quarterly per clock. And here's a partial list of clock plant, general plant installations, clocks of located in banks. Looks like we've got one in the State House in Massachusetts, the Boston Terminal Station, which my guess is probably South Station. Of course, lots of them in New York City. I'm sure some of these, I think the Grand Central one is still there in operation. Again, self-winding synchronized clocks in the United States and universities. There's one at Yale University, or there's a system at Yale University, or school installations, Prominent Tower, and others. And here are the awards they won at the World's Columbian Exposition 1893, which, for those of you who are not familiar, this World Expo was basically the end of the AC versus DC argument. AC electricity was demonstrated and became widely accepted after this exposition in Chicago. So pretty cool stuff. A lot happened in this exposition that basically drove our modern industrial age that we live in today. A lot of things went down during that exposition, and apparently including these clocks. So that's it for the catalog tour. Okay, so things are a bit of a mess today in the shop because I'm setting up the shop clock. Now, a lot of folks, a lot of the technology guys on YouTube have a clock in the shop, and I want to show you the one I'm going to set up. This is called a self-winding clock from the Self-Winding Clock Company of New York, and it's one of the coolest things I think I've ever seen in clock making. Basically, it has this motor down here, which is actually a vibrational motor that winds the clock. The mechanism is akin to, the winding mechanism is akin to a bumper, I think a bumper winding movement. And there's a synchronization solenoid over here that will synchronize it to the Western Union time standard from the U.S. Naval Observatory, Washington, D.C. At least back in the day when these things were synced to the time standard. Check this out. It automatically rewinds the mainspring every hour a little bit. It basically does one turn once an hour, so it always has the same tension on the mainspring. But you can manually do it as well by simply pushing this button up here. And you can see how that works. And the clock, not sure if you could see it, but I'll show you once in the next clip here. This was a Western Union clock. Okay, this clock, as you see, property of Western Union, and I've got it mounted to the ceiling with the big lag bolts hanging off that lag bolt. And you can see the 100-year-old wiring. I don't know how old it is. Maybe this is all cloth, so who knows? It could be the 20s. I've got rigged with D cells. I inherited this from a friend of mine who did the wiring. But this is all original wiring. It's these Farn stock clip things. I've never seen these used commercially before till now. Here's our feature: is the synchronization. So once every time we come up on within 2 minutes of an hour, which it's set to right now, you can hit this solenoid, come down, and then adjust the position. So we bring it around. Okay, so every time it comes within 2 minutes, I'll solenoid come down and boom, align it. So I've got that set up here too. I'm going to run some wires out the top for the solenoid so I can synchronize it with my GPS clock that I use for timing all of my clocks. So we'll continue with the assembly here. Alright, so you open it up, and I've leveled the unit. Here's the movement, here are the size D batteries. So now it's time to install the pendulum, and followed by the wiring up here, and actually maybe I'll do the wiring up here first and then the clock face and the pendulum. Okay, here's the connection for the synchronization solenoid, and I'm using this twisted pair shielded silver plated Teflon, as you can see, silver plated, from Bay Associates Incorporated in Palo Alto. It's nothing like using some mil-spec spaceflight qualified wire for a 100-year-old clock. Okay, so we've got the pendulum installed and everything's ticking. And the next step is going to be to install the clock face and test everything out. Okay, it's taking shape. So there we go. Got the dial installed. Next we have to do the glass. And I can access the pendulum right down here. I think she'll need some fine tuning and adjustment. But I didn't want to regulate the clock till I had it in the final position. Okay, here's the completed clock. Now the glass is held in there with these brass tabs. And you know, it's old. It's about as good as she'll get. And there's this cool thing here. If you look over here, there's this winding arbor, and this is how you open it. And actually, a lot of people will just leave that key in there. Okay. And here it is. Here's the clock, and there are these brass tabs. I mean, you just bend them over. There's 4 of them. And that's what holds the glass in, as well as the gravity pushing down on it. And then it sandwiches against the dial itself. So this is the shop clock, the new shop clock. All right, here's a final shot of the shop clock here. Right above the toolbox where it ought to belong. And it's keeping good time. So we'll be regulating this over the next week or so. Here we are testing out the relay controller, and this is the line right here from the clock. And here is the one of these inexpensive control boards. Check this out. Here's the modifications I've made. I basically sent the VCC to the COM of both relays, and I'm using this relay as just a binding post for now. And then I'm using the normally open contacts for the other terminal, and I put a suppressor diode across there because there's a lot of back EMF. There's a lot of inductance in this coil. So if we hit this right here, oops, hard to do while holding my camera. There you go. The clock just set. So we'll move the phone over here to watch it go. There we go. All right, let's see if we can get it into a good position. All right, should be able to see it. Okay, here goes 3, 2, 1. There we go. Okay, it's pretty sturdy. Now it seems to be a minute ahead, so I think what I'll do, there's not a lot you could do about that. It has to do with the alignment of how this minute hand is built. I can't change that right now. So I think what I'll do is I'll perhaps change the software so it only does it when it's a minute ahead. We'll see. We'll take a look, see how hard that is to do. But the driver circuit does work. Okay, next we want to see if we can power. This is the inside of my GPS clock. It's getting no signal, so nothing's displayed right now. We want to see if we can power from the wall wart. This one is too weak, but this one powered no problem. I'll demonstrate. So we'll take a shot over here. Off. And here we go. 3, 2, 1. There we go. So that should work for synchronizing. I think looks like it's 45 seconds fast. So we'll have to make the software wait till a minute 45 and then hit it. All right, so here we've got the relay module mounted to the clock and wired up. I'll reinstall everything. I'm adding a daylight savings time switch, which was badly needed, and I've wired the I/O to the main board here. So you can see I've added the a pull down for the daylight savings time switch I/O pin 8, and I/O pin 7 is the output to turn over the relay, and then I added a couple power pins down there and a 150 microfarad Nichicon cap for power supply decoupling when throwing this load on and off. Hopefully that should help. All right, so we're going to put all this together, and we'll leave it open, but we'll start to do some software testing with all this in one piece. Okay, so we're coming up on 2100. Here is the Arduino code. Here's the GPS clock. There's the wire all the way over to this unit right here. So let's see if we can make this New York self-winding clock. See if we can put this thing onto atomic time according to the GPS. So I'll set the camera up like that. So we're at about 1 minute 20 seconds to go. And let's see if we can ring it in. Should jump ahead about 45 seconds or so when it clicks on, because there's a slight offset in the minute hands on this clock by about 45 seconds from true, and there's nothing we could do about that. Okay, 50 seconds. Go 20 seconds. All right, here we go. Okay, 10 seconds, 10, 9, 8. All right, watch for it. 3 seconds. Yes. All right. So now this clock is on atomic time. Very cool. That was cool. Thing now is now set up. We have we've got a couple new features here. First of all, one thing I did not have before is actually a switch for daylight savings time, which is super handy. And then over here, so I've got on GMT where it does not apply the daylight savings time. Over here you can see the I/O wired for the relays. I'm going to clean this up with some zip tie in a minute. There's again the relay. I'm going to clean up this harness here, and it's coming up on the hour. Another trick I've done is I've set the code up to have a little delay, so when the hour comes around there's a slight delay on the clock before it turns over. Okay, I gotta go. Hang on. More later in a minute. Okay, here we go. We're about to strike another hour here. And there's the setup with all the wire ties and everything into place and the I/O. So you can see we've got the time zone, the daylight savings time, and the relay I/O all wired in. Clock is wired in. So we're going to do a quick demo of this thing. The clock is over here. Alright, in a few seconds we'll do it. Here's the GPS clock all wired up. I'll close it up later. There's the Arduino code. And here's the clock. It's set up to be 45 seconds after the minute. It's set up to the minute right now. So any second now, 5 seconds. Ready? Should synchronize. There it goes. Perfect. Right on time. Okay, here's the GPS clock in its final position with the right labels, and there's the sky that it sees to get the time. And I've got the wiring hooked up for the relays to drive the solenoid, and of course the programmer/power interface. Awesome. And now it actually works on local time, which is a new feature on this clock. It's daylight savings time on and off. So cool. And it's hooked up over here. As you can see, they're both in close agreement, which is awesome. So this big clock here is now running on GPS time. There it is winding. It's hard to catch that on video. There it is winding itself again. It's hard to catch this on camera. So you got a piece of it. It takes about 10 or 12 seconds to wind.